Have you ever wondered if alien life could exist in water worlds, hidden away in the vast reaches of space? These celestial bodies, known as water worlds, are thought to be swathed in boundless oceans, their surfaces obscured beneath leagues of liquid mystery. Imagine an expanse where the horizon stretches out into an unending sea, a world where the sky meets the water in an eternal dance. Water, this simple yet essential molecule, is the lifeblood of our own blue planet. It shapes our landscapes, drives our weather, and more importantly, it is the cradle of life as we perceive it. The presence of water on Earth is the reason we exist, the reason life bloomed in its myriad forms. So what if, in the infinite cosmos, there exist other worlds where water is as prevalent as it is on Earth? Could they harbor life? Dive with us now into the deep space oceans of these water worlds. So, what exactly are these water worlds, and why should we consider them as potential homes for alien life? Let's dive right in. Imagine a planet, but unlike our own, this one is absolutely dominated by water. We're talking about an immense global ocean, possibly reaching depths of hundreds, if not thousands of kilometers. These are the water worlds, celestial bodies where water is the primary geological component, not just a feature. But how does this vast expanse of water affect the planet's structure? Beneath the deep surface of these water worlds, the pressure increases dramatically, leading to the formation of exotic forms of ice. This isn't your regular freezer ice, but high-pressure ice, such as Ice 7, which remains solid even at temperatures that would melt ordinary ice. Interestingly, sandwiched between this ice and the planet's rocky core, there may be a layer of searingly hot, high-pressure water. This unique environment could harbor life, potentially even forms of life we can't yet imagine. But you might be wondering, why is water considered so crucial for life? Well, water is a universal solvent, capable of dissolving a vast array of substances. This makes it an excellent medium for life's chemical reactions. In fact, every life form we know of on Earth requires water to survive, making its presence a key ingredient in the search for extraterrestrial life. Moreover, water worlds may have stable climates. The vast oceans could act as a global thermostat, distributing heat around the planet and preventing extreme temperature variations. This stability could further enhance the potential for life. But it's not all smooth sailing. There are challenges. For instance, without land to break up ocean currents, these worlds could experience superstorms of unimaginable scale, and the high-pressure ice could potentially block life-supporting nutrients from reaching the ocean's depths. Yet, these challenges do not deter our curiosity. They only fuel our desire to explore and understand these fascinating water worlds. As we continue our voyage, we delve into the depths of these extraterrestrial oceans. Across our galaxy, scientists have already identified several promising water worlds. These celestial bodies are not only fascinating in their own right, but they also hold the tantalizing possibility of hosting alien life. Our first stop is Europa, one of Jupiter's largest moons. Europa is believed to have a subsurface ocean twice the volume of all Earth's oceans combined. This icy moon's ocean, hidden beneath a surface of solid ice, could be warmed by the tidal forces exerted by Jupiter, making it a potential habitat for life. Next, we venture out to Enceladus, a small moon orbiting Saturn. Despite its size, Enceladus is of great interest due to the geysers of water vapor that it ejects into space. These geysers hint at the presence of a subsurface ocean, possibly warmed by the moon's internal heat. If such an ocean exists, it could be a haven for extraterrestrial organisms. Further afield, we find Kepler-22b, an exoplanet located about 600 light-years away from us. This planet is located within its star's habitable zone, also known as the Goldilocks zone, where conditions might be just right for liquid water to exist. While Kepler-22b's composition is still a topic of debate, some scientists suggest it could be an ocean world, with vast seas that might support life. Finally, we arrive at GJ-1214b, another exoplanet situated 40 light-years away. This intriguing world is enveloped by a thick, water-rich atmosphere, leading some to nickname it the Water World. If life exists here, it would have to adapt to extreme conditions, potentially leading to forms of life beyond our wildest imaginations. Each of these water worlds presents unique environments that could potentially support life. The vast oceans beneath icy surfaces, the geysers spewing water vapor into space, the potential for vast alien seas, and the water-rich atmospheres all serve as a testament to the diverse conditions in which life may thrive across the universe. Could these distant oceans be teeming with life just waiting for us to discover? Only time and continued exploration will tell. Discovering life in these distant oceans is no easy task. That's an understatement. The challenges scientists face in detecting life forms in these water worlds are numerous and complex. Imagine, for instance, the sheer depth of these oceans. We're talking about bodies of water that could be hundreds of kilometers deep, far deeper than any point on Earth's oceans. This means the pressure, the cold, and the darkness at those depths are beyond anything we've experienced. Now consider the distances. These water worlds are light years away from us. Sending probes to them, let alone retrieving samples, is currently far beyond our technological capabilities. And even if we could somehow get there, how would we penetrate the thick ice covering these oceans? How would we navigate in the pitch-dark, high-pressure environments? And how would we recognize alien life if we found it? After all, life in these worlds could be based on completely different biochemical principles than life on Earth. These are the challenges that confront us. But they're not insurmountable. We're developing new technologies that could one day help us overcome these hurdles. Robotic explorers, for example, are becoming increasingly sophisticated, capable of operating autonomously in extreme environments. We're also making strides in astrobiology, the study of life in the universe, which could provide us with the tools to recognize extraterrestrial life forms. And then there's the James Webb Space Telescope, set to launch soon. This marvel of engineering will be able to detect the chemical signatures of life in the atmospheres of distant planets. If there's life in the oceans of these water worlds, it might leave traces in the atmosphere that this telescope could pick up. The journey to uncover life in these water worlds is fraught with challenges, but the rewards could be extraordinary. Imagine the scientific breakthroughs, the philosophical implications, the sheer wonder of discovering we're not alone in the universe. That's a prize worth striving for. Imagine the moment when we finally confirm the existence of life in a distant water world. This discovery would not just be a scientific breakthrough, but a monumental shift in our understanding of life and its place in the universe. The moment we find life forms thriving in the icy depths of a far-off water world, we would know that we are not alone. That life, as we know it, isn't confined to the boundaries of our home planet. Consider the kind of life forms we might encounter. They could be simple, microscopic organisms, similar to bacteria or plankton. Or they could be complex, multicellular entities, entirely different from anything we've ever seen. Regardless of their complexity, their mere existence would redefine our understanding of life's tenacity and adaptability. This would also force us to rethink our definition of habitable zones. Currently, we look for planets in the so-called Goldilocks zone, where conditions are just right for liquid water to exist. But if life can thrive in the deep, icy oceans of a water world, far from the warmth of its star, then perhaps our search parameters for extraterrestrial life have been too narrow. The discovery would also have profound philosophical implications. It would challenge our beliefs about our place in the universe and our role as sentient beings. Are we unique, or just one of many forms of intelligent life scattered across the cosmos? And let's not forget the potential technological implications. Studying alien life forms could lead to new biological insights, advancements in medicine, or even novel materials and technologies. The possibilities are as vast as the universe itself. Finally, this discovery would underscore our responsibility as stewards of life. Recognizing that life can exist in extreme environments, we must take greater care in exploring space, ensuring we do not inadvertently harm or disrupt these alien ecosystems. The discovery of life in a water world would undoubtedly be one of the greatest milestones in human history. The exploration of water worlds is like a journey into the unknown. As we've journeyed together through the vast expanse of this topic, we've seen the tantalizing potential that these celestial bodies hold. They are not only fascinating from a scientific viewpoint, but also as potential hideouts for alien life. Imagine the myriad of possibilities that these aquatic realms present, the diverse life forms they could harbor. Yet, the exploration of these worlds is not without its challenges. The extreme conditions, the vast distances, and the technological hurdles we must overcome are daunting. Despite these obstacles, the implications of discovering life in these water worlds are profound. It would redefine our understanding of life and our place in the cosmos. It would prompt us to rethink the boundaries of life itself. As we continue to explore these intriguing water worlds, who knows what extraordinary secrets they may reveal to us?